Have you ever wondered how Netflix knows exactly what movies to recommend to you? Or how Amazon instantly finds every product in its massive database? Today, let's discuss the techniques that power these systems. Techniques we can master to level up our database skills. Hello learners, welcome back to Constant Learners. Today we're diving into two powerful database concepts, specialization and generalization. Stick around for an amazing example coming in the end. Imagine you open a cabinet and find this massive box of assorted candies, chocolates, lollipops and toffees all jumbled up together. Now, when you're craving specifically chocolate, you have to dig through everything to find what you want. Frustrating, right? Now, what if you reorganized them? Taking that big box and separating the candies into specialized containers. That's specialization. Dividing a general set into specific categories. But sometimes the opposite approach is better. If you had those separate containers taking up too much space and decided to combine them into one organized box, that would be generalization. Combining specific categories to a general set. But the real question is, when should you use which approach? The answer could mean the difference between a lightning fast database and one that crashes under pressure. We'll get to that soon. Now, to put it in simple words, in specialization, we divide a general entity, and in generalization, we combine specific entities. In database world, these concepts are like superpowers when designing your entity relationship models to handle inheritance or hierarchy between entities. And knowing when to use each makes all the difference. Now, before we go deeper, I have a quick question for you. Do you think Facebook's user database uses specialization, generalization, or both? Think about it. We'll discuss the answer in the end, and I'm sure you will be surprised. Let's get into it. Now, in DBMS, these concepts aren't just theoretical. They directly impact how efficiently your database runs. So, this is a practical concept that we need to understand to make our database designs more powerful, right? Now let's start with specialization. In specialization, we can say that it is the top to bottom approach. Why? Because the process of creating sub-entities or subclasses or child entities from a more general entity, that is the parent entity, based on some distinguishing characteristics, that is specialization. Alright, so specialization starts with a broad entity, that is the parent class, and divides it into more specific ones. Think of it as a parent to children relationship. Why? Because we are going from the parent to the children. We are dividing the parent into its children. Right? Now, without proper specialization, our queries become painfully slow. Right? And our database bloats with null values. For example, imagine a general entity employee. Without specialization, you might have one massive table with columns like employee ID, name, address, phone number, specialty, etc. and so on, right? But there can be different employees working in a company. Some may be managers, some are engineers, admins, HR, and so on. And each of them have their own qualities that need to be stored in the tables. For example, engineers may require the column tech stack. Managers may require the columns team size and department, and so on. Without specialization, our database becomes a wasteland of empty values, right? If we store everything in one place, our database becomes the wasteland of empty values and the queries take forever. Right? So, what can we do? With specialization, we can divide employee into two separate tables, two separate entities, that is engineers and managers. So engineers can have their column tech stack and managers can have their columns like team size and department. And suddenly our queries will start to run faster and our data will be more organized and the application scales. Right? Now imagine we are redesigning a hospital's database system where queries run very slow. But slow queries aren't just annoying here, they could literally be life or death. Right? So what happens in many poorly designed hospital systems? They start with one massive table. Let's say we have the staff table here and it looks like this. Right? Look at this mess. It's a single table trying to store everyone who works at the hospital, like doctors, nurses, administrative staff, everyone, all crammed into one table with dozens of columns. I have made very little columns here, but if I have to store everything in one place, our table is going to be an extremely messy one, right? So this creates 4 critical problems. First is too many null values. See, for the doctor, we need the specialty department, doctor cardiology, doctor neurology. But for nurse and administrative, it's going to stay empty. Similarly, in case of shift time column, it's useful for the nurses, but for doctor and administrative staff, we'll have null values. And for department name, the administrative department will have names, but doctors and nurses won't. So again, there'll be null values, right? So there's going to be too many null values, and because of this, there's a lot of wasted storage space, right? Because these nulls aren't just empty, they're actively consuming resources. In a hospital with thousands of staff, this adds up very fast, right? And thus performance becomes a nightmare. Every query becomes a slog through irrelevant data. Imagine a doctor waiting precious seconds for patient info during an emergency because the database is crawling through this mess. This leads to database integrity issues because it breaks normalization rules, making it nearly impossible to enforce role-specific requirements. If you don't understand normalization, I will link the video above as well as in the description. So how do we fix this disaster? See, this is where the magic of specialization comes in. Specialization lets us transform this chaos into clarity by dividing a general entity into more specific sub-entities based on their unique attributes. So instead of one bloated table, we create a base staff table with common attributes like staff ID, name, contact and hire date. These are the common attributes, right? And then we create the specialized tables, that is separate tables for doctors, nurses and administrative staff. So for the doctors table, we only need the staff ID, and through the staff ID, we can determine the specialty, that is staff with ID 101 is Dr. Khan and his specialty is cardiology. 104 is Dr. Ritu and her specialty is neurology. Right? Same for the nurses. The nurse 102 staff is Nurse Sasha and her shift time is night. For the administrative table, staff ID 103 is Mr. Verma. He is in the billing department. Alright. So now each table has a foreign key relationship back to the main staff table, and that foreign key relationship is through the staff ID. Right? Staff ID is common in all 3 of these tables and it links back to the main staff table. Alright. So this is the foreign key relationship. Again, if you don't understand what a foreign key is, I'll link the video above and in the description below. Make sure to watch that. Now let's see the transformation. See, before it was a confusing table with 70% null values. But now suddenly we have a dramatically cleaner structure with organized tables where every field has a purpose. No more database spaghetti. Each table has a clear purpose and relationship. Now, not only is this more efficient for storage, but queries become lightning fast. And since the queries are lightning fast, when a critical patient needs information about their specialist, the system doesn't waste precious milliseconds sorting through nurse schedules or admin department codes, or wait for a bloated query to complete. Instead, we get it all instantly, right? And thus, there is perfect data alignment. So, each staff type only stores data that's actually relevant to their role. Just like you wouldn't keep kitchen utensils in your bathroom, you don't store nurse shift schedules in the doctor's table, right? And thus it ends the null wasteland. Those endless fields of null values, they're all gone. It gets easier to maintain and query, and thus your database storage requirements could shrink by 40 to 60% instantly. This specialization approach doesn't just apply to hospitals. Think about e-commerce platforms, educational systems, or any application where different user types have unique attributes. The principle remains the same, right? But here's what most tutorials won't tell you about specialization. It's not just technical efficiency. In real-world applications like hospitals, this design pattern directly translates to better service, faster data retrieval, that means faster patient care, which means less waiting, and finally, potentially better outcomes. Alright, so that was all about specialization. Now let's flip the script. Alright, because sometimes the problem isn't that you have too much in one place, it's that you have the same thing in too many places. So generalization works in reverse, identifying common features across entities and creating a parent entity. So the process of extracting common features from two or more entities and creating a new general entity, that is superclass or parent class. That is, we start with specific entities and abstract them into a more general one. This approach prevents one of the deadliest sins in database design, redundancy. Alright, this improves redundancy. This can be related to bottom to top approach. For example, we have entities car and truck. Car has attributes make, model, engine and seats, and truck has attributes make, model, engine and load capacity. Right? Now in this case, both of these entities have three common attributes. That is make, model, engine, make, model, engine. Right? These common attributes can be merged into one parent entity, that is vehicle. Alright, again, let's go into the gist of it using the hospital database. Let's say a patient walks in through the emergency doors. The first question, if that is an inpatient or an outpatient. What is an inpatient? A person who receives medical care and treatment but is not admitted to the hospital. And inpatient is a patient who is formally admitted to a hospital or medical facility and stays there for treatment, observation or diagnostic procedures. Based on the answer, the staff pulls up a completely different database form, right? See, in this hospital database, we have two tables, outpatient and inpatient. In case of outpatient, we have patient ID, name. Inpatient also has patient ID, name. Outpatient has doctor name. Inpatient also has doctor name, right? So what are we noticing? That both of these tables have redundant attributes, right? This creates three critical problems. First is, these are duplicate attributes, alright, leading to dangerous data redundancy. If Dr. Smith changes her name after marriage, you need to update it in both the tables. If not, your data becomes inconsistent. If someone's contact info changes, you will have to update it in multiple places. This is how data inconsistencies happen, right? And this leads to storage inefficiency because you're essentially paying to store the same information twice. This leads to maintenance nightmares. Every schema change means updating multiple tables, increasing the chances of errors. Alright, this isn't just an academic example. Inefficient hospital databases literally cost lives when doctors can't access patient information quickly. This is where generalization saves the day. What happens in generalization? We identify the common attributes across all the entities and create a shared parent entity. In this case, it is the patient, right? The common attributes, patient ID, name and doctor name have been merged into this simple single table, right? So one update affects all records. Clean, consistent and efficient. Alright, and outpatient will have the visit date, Inpatient will have the admission date and room number. So now when Dr. Smith updates a name, it changes in one place and automatically applies to both inpatient and outpatient. One update, consistent data everywhere. What are the key benefits here? Single source of truth. The common data stored once means no more inconsistencies. There's reduced storage footprint, which avoids redundancy. That means lower database costs, right? The maintenance is simplified. Updates happen in one place, not scattered across the tables. And this leads to powerful data abstraction. You can run queries across all patients regardless of type while still preserving their specific differences, right? So if a patient comes in for a routine checkup, he's an outpatient, right? Because he's just coming for a checkup. But suddenly he needs to be admitted. So now he becomes an inpatient. Now without generalization, we would need to delete their record from one table and create the record in another table. But with our generalized model, what happens? We just need to delete their record from one table, that is outpatient table, and create it in the inpatient table. The record will be linked to their existing patient ID, right? So their history remains intact and their identity stays consistent. Alright? I've seen hospital systems where patients literally appeared as different people in different departments because of poor database design. With generalization, you create a cohesive view of each person across your entire system. Alright? So the real power comes when you know exactly when to use each approach. Use specialization when you have entities with many null values or type specific attributes, and use generalization when you see the same attributes duplicated across multiple entities. The best database designs often use both techniques, creating a hierarchy that perfectly maps to your real world data. Now remember that Facebook question? Now Facebook actually uses both the techniques. They generalize common user attributes into a base user entity and then specialize different account types for businesses, creators, and personal accounts. This hybrid approach is what allows them to manage billions of users efficiently. If you've made it this far, you're clearly serious about leveling up your database skills. Hit like if this helped you understand these concepts better. In the comments, tell me which database concept would you like me to explain next. I read each and every comment. And in the next video, we will discuss query optimization and various techniques used for query optimization. Until then, keep learning, keep growing, and I'll see you in the next video. Thank you so much for watching.